Okay, thank you. Yes, good morning, friends. Again, welcome back. The sixth day of the GATE coaching in mathematics. So, yesterday, we started linear algebra and we have discussed the matrix algebra and other things. Then, Gauss elimination method, Gauss Jordan method, and then different methods we have done. And we are dealing with uh, eigenvalues and eigenvectors. Once again, just we stop near the properties of eigenvalues and eigenvectors. So first, let's go through the definition once again before going to the properties. That A, B, and n by n matrix, there exists a non-zero vector x such that Ax is equal to lambda x. Then lambda is called eigenvalue of the matrix, and the x is called the corresponding eigenvector corresponding to the eigenvalue. Six minus 3. What is the definition of eigenvector? Ax is equal to constant times x. So can you take anything constant? If you take something out common, then this vector should come here. So if you take 3 common, what happens? It becomes 2 minus 1. That means constant times x. So Ax is equal to lambda into x. So lambda is 3. So you can say this x is a eigenvector. Now let us after finding out the procedure to find the eigenvalues in a matrix, that n by n by square matrix, lambda with the eigenvalue of a with the x being the corresponding eigenvector. Then we have a minus lambda I times x is equal to 0. This is how we get x is equal to lambda x not equal to 0. So if you take x common, this is what we get, which is a homogeneous system of equations, and this is your coefficient matrix. We know that for a homogeneous system of equations, for the existence of non-trivial solution, the coefficient of the determinant of the coefficient matrix must be 0. So that's why determinant of a minus lambda I is 0. This is called characteristic equation. And if you find the roots of this, we get n roots. If A is a n by n matrix, you get nth degree polynomial characteristic equation. Nth degree polynomial has n roots, and the roots are called characteristic roots or eigenvalues or latent roots. That's what we studied yesterday. So eigenvalue of a matrix may be 0, eigenvectors of a matrix must not be 0. And then we have done spark problems, and then we see some of the important properties of eigenvectors. The properties you have to learn somehow, because at times in the examination they are directly asking the properties. If lambda is an eigenvalue of matrix A corresponding to the eigenvector x, then lambda power n. Question may be lambda is an eigenvalue of A. Let us say lambda is equal to 2 is an eigenvalue of matrix A, and which of the following is an eigenvalue of A cube? I repeat the question. If lambda is equal to 2 is an eigenvalue of matrix A, which of the following is the eigenvalue of A cube? So what happens? Lambda is an eigenvalue, then lambda power n is an eigenvalue of A power n. So A cube will have a lambda cube will be an eigenvalue of A cube. So lambda is equal to 2 means 2 cube, that A cube will be an eigenvalue. Problems are of that type, they are asking directly basing on the properties of eigenvalues. So we have to learn these properties of eigenvalues very, very thoroughly. There is no escape here, there is no trick here, you have to read them, that's all. If lambda is an eigenvalue of A, then k times lambda is an eigenvalue of Ka, x corresponding to the same eigenvector x, and the same eigenvector k is a constant, then this is the principle. If x is an eigenvector of A, then x cannot correspond to more than one eigenvalue. There can be only one eigenvalue corresponding to each eigenvector. And fourth principle is the matrix A and A transpose have same eigenvalues, because while finding the eigenvalue we are finding determinant of A minus lambda I. Lambda is a constant, I is a identity matrix, A is symmetric matrix. So A transpose is A, determinant of A equal to determinant of A transpose, because of the property a matrix A and A transpose have the same eigenvalues. Next property is lambda is an eigenvalue of, then 1 by lambda is an eigenvalue of A inverse. There is a very important consequence based on this problem. Let us say the question may be like this: lambda is an eigenvalue of, then 1 by lambda is an eigenvalue of A inverse. If 0 is an eigenvalue of A, repeat it. If 0 is an eigenvalue of A, which of the following is true? A, determinant of A not equal to 0. Determinant of A is 0. A is singular and A is non-singular. Okay, when lambda is an eigenvalue of A, what happens? Determinant of A becomes 0. A inverse does not exist. What happens is 1 by lambda becomes infinity. It cannot happen. And in the equation also, if lambda is equal to 0, what happens to the actual equation? A minus lambda I becomes. So this is what we have. Yes. What happens when lambda is equal to 0 in eigenvalue? We get determinant of A becomes 0. When determinant of A becomes 0, A is singular matrix. So determinant of A does not exist. So these type of consequences they are asking based on the properties of eigenvalues. Be very careful with these properties. The next one is eigenvalues of a diagonal matrix or its diagonal elements. Take it granted, if a diagonal matrix is given, the eigenvalues are simply that means, so I use this pad. Say for example, if I use a matrix 2, 3, 0, 0, 1, 0, 0, 0, 3. So if you take a matrix like this, what happens to A minus lambda I? 2 minus lambda, 3 is 0, here 0, 1 minus lambda, 0, 0, 0, 3 minus lambda. So what happens to determinant of A minus lambda I? So even if you have a 0 here, let us say, what happens then? 2 minus lambda into 1 minus lambda into 3 minus lambda is equal to 0. So what are the eigenvalues? Lambda is equal to 1, 2 and 3. What are those things? They are nothing but the diagonal elements. So you have seen that. Okay? Diagonal elements. So that way, whenever we have in the diagonal matrix, the eigenvalues are nothing but diagonal elements of the matrix. Okay. The eigenvalues of triangular matrix are also its diagonal elements. I have just shown the same example. The eigenvalues of similar matrices are same. If lambda, this is also one important statement. If lambda is an eigenvalue of, then determinant of A by lambda is also an eigenvalue of adjoint of A. These principles are very, very important. Repeatedly I am telling you, please, you have to get them by heart. And most of the problems, some of the problems, I don't say most, are depending on the principles. Two distinct eigenvectors corresponding to two distinct eigenvalues are linearly independent. What does it mean is, if you have lambda 1 and lambda 2, two eigenvalues which are not equal. And then the corresponding vectors, eigenvectors x2, x2 are linearly independent. Okay. Then for a real symmetric matrix, the eigenvectors corresponding to two distinct eigenvalues are orthogonal. A real symmetric matrix must be a symmetric matrix. The eigenvectors corresponding to two distinct eigenvalues are orthogonal. Orthogonal means their dot product becomes 0. The eigenvalues of a real symmetric matrix are always real. Next, this is an important point. Sum of the eigenvalues is trace of the matrix. Trace means the sum of the diagonal elements is called a trace. So means here trace of A means sum of diagonal elements. So this is equal to sum of the eigenvalues. So this is important property. If A and B are square matrices and A is invertible, then A inverse B and B into A inverse have the same eigenvalues. Lambda is an eigenvalue of A, then lambda plus K is an eigenvalue of A plus Ki. If lambda is an eigenvalue of an orthogonal matrix A, then 1 by lambda is also an eigenvalue of eigenvalue. So work out this formula, these principles, read these principles thoroughly. So another type of small multiple choice question, very good multiple choice question from eigenvalues, eigenvectors can be like this. If two eigenvalues of the matrix are given, what is the third eigenvalue? So you need not find the eigenvalues here. You are asking the tricks. There are some here. So when a problem is given like this, what is the third eigenvalue? We need not find the eigenvalues. We have a principle. The trace of the matrix is equal to sum of the eigenvalues. Trace means sum of the principal diagonal elements 2 plus 5 plus 3. 2 plus 5, 7 plus 3, 10. That is trace is equal to sum of the eigenvalues. Let us say the third eigenvalue is A. So A plus 1 plus 3, that is sum of the eigenvalues is equal to 10. So A becomes 6. This type of questions you may have. And I told you some other basic, and if lambda is equal to lambda is equal to 3 is an eigenvalue, then what is the eigenvalue of lambda cube? This type of problems we are getting. So A is equal to 1 minus 6 minus 4, 0, 4, 2, 0 minus 6 minus 3. Then what are the eigenvalues, eigenvectors? So carefully you write the determinant, find the determinant, equate them to 0, determinant of A minus lambda equate to 0 to get 1, 1, 0 are the eigenvalues. So this is one more important problem in the sense that, see here, the eigenvalues are repeated eigenvalues. So corresponding to lambda is equal to 1, you substitute, this is the system of equation that we get. So because lambda is equal to 1 is an eigenvalue twice, a repeated eigenvalue, 2 rows will be 0. So you have 1 equations and 3 variables. So by assuming n minus r arbitrary constants, so let us say z is equal to k and then y is equal to j, x is equal to k1, then we get a vector like this. So lambda is equal to 1, 1, repeated eigenvalue. You have seen that, right? So corresponding to lambda is equal to 1, the eigenvectors are now written as 1, 0, 0, 0, minus 2, 3. This we have to understand. That means question may be, when lambda is a repeated eigenvalue, then corresponding to that there will be 2 independent eigenvectors. So lambda is equal to 0, and if you put lambda is equal to 0 in this, these are the equations. If you solve them, we get the eigenvector 2, minus 1, 2. here to simplify this, you get this. Find the eigenvalues and the corresponding eigenvectors of the matrix 2, 2, 0, 2, 5, 0, 0, 0, 3. Determinant of A minus lambda, find them, then clearly. So the diagonal elements are there, but it's not upper triangular or lower triangular. So diagonal elements exactly cannot be the eigenvalues. So if you find the characteristic polynomial and find the roots of the polynomial, we get lambda is equal to 1 is a root. So with this synthetic division, 1, 3, 6 are the eigenvalues. So corresponding to 1, this is the equation. This A minus lambda into x becomes like this. So if you solve them, x1 is minus 2, 1, 0. So corresponding to lambda is equal to 3. To solve these equations, you get x2 is equal to 0, 0, 1. We put lambda is equal to 6, then the matrix equation becomes like this, minus 4, 2, 0, 2, minus 1, 0. So if these two equations are dependent, that means if we multiply the second row with 2, minus 2, we get the same equation. So they are dependent. So these are the independent equations. From this, 2x1 minus x2 is equal to 0 and 2x1 is equal to x2. And last one is minus 3x3 is equal to 0. It means that x3 must be 0. When x3 is 0, and if you put x1 is equal to some constant k, then x2 will be 2k. So k, 2k, 0. So or else k times 1 to 0 is an eigenvector corresponding to lambda is equal to 6. Find the eigenvalues and eigenvectors of b is equal to 2a square minus 1 by 2a plus 3i. So a is so and so. This is another problem. You can have to calculate this 2a square minus. But one advantage is a 2 by 2 matrix is not that easy. That's that difficult to evaluate these things. So that is sometimes we are getting problems like also. Find the sum and product of eigenvalues. As I said, the important property, sum of the eigenvalues is equal to trace of the matrix. What is the trace of the matrix? 2 plus 1 plus 2, 5. So sum of the eigenvalues is 5. And another property is sum is okay, trace of the matrix. Product of the eigenvalues is nothing but determinant of the matrix. You find the determinant of the matrix, then that will be equal to product of the eigenvalues. So 2, 3 minus 2, minus 2, 1, 0, 1, 0, 2. So if you expand determinant, 2 into 2 minus 0, minus 3 into minus 4 minus 1, minus 2 into minus 1. So this becomes 4 plus 15 plus 2. So the product of eigenvalues is 21. So these problems you may get in the examination. So we have then some gate questions, how they are asking the gate questions. So Mij, diagonal elements are all 0. Mij is equal to minus Mij. That means minimum number of elements required are this. So Mij is equal to minus Mij and diagonal elements are 0. So if you take a matrix, the diagonal elements are 0 and if A, B, C like this and they are minus A, minus B, minus C, minus D. So let us say if you stop with only 3 elements, 3 by 3 matrix, that means this will be minus C is also there, minus C also there. So minimum number of elements required. So you get this is once you know upper triangular elements, you don't need the lower triangular matrix. Elements of the lower triangular matrix. That is the principle. So this is a 4 by 4 matrix. Okay. So diagonals are zeros. How many elements are above diagonal? 3, 2, 1. then diagonal comes. Those same elements will be in the opposite and the opposite sides. 3, 2, 1. So how many? 6. So that's how we have to imagine this question. Sum of the eigenvalues of the matrix is, sum of the eigenvalue is nothing but trace of the matrix 2 plus 5 plus 7, 14. This is the question asked in 2020. That's why I am telling you, read the properties properly, and you have been asking me tricks. These are the properties, they are not the tricks. They are the basic properties. If you know the properties well, you can answer the questions easily. If a 4 by 4 matrix P is given below like this, the eigenvalue of P, the eigenvalue of P are. So we have two important properties here. One is, because a 4 by 4 or 5 by 5 difficult to calculate also. So check the trace of the matrix. 6 plus 6, 12 plus 3, 15. In the given options, which of the option has total of eigenvalues as 15? Here what happens? 1 plus 2 plus 3 plus 4. 3, 3, 6 plus 4, 10. So A is not the answer. 0 plus 3 plus 6 plus 3. 0 plus 3 plus 6 plus is 15. But don't come to a conclusion, because other things may also have a sum of 15. So here 3 plus 4, 7 plus 5, 12 plus 7, 19. Now A and C are not the answers. Here see what happens. 1 plus 2, 3 plus 5, 8 plus 7, 15. So B and D are having a sum of eigenvalues equal to trace of the matrix. So then which one is correct? Then you have to verify the product of the matrix also. How do you get product of the matrix? Determinant of the 4 by 4 matrix. So if you consider determinant about this column, first column, then minus 2 into minus 2 means the second element. So minus into cofactor is plus 2 into, if you close this column and this row, the remaining is 130, 061, 016. If you find this determinant of this with respect to this minus 2, then you will get the determinant value. Let us say what is that? We get 70. Determinant is 70 here. So the product of eigenvalues here is 2 into 5 into 7. That comes out to be 70. So your answer is B. So the two important things are, one is trace is equal to sum of eigenvalues. The second point is determinant of matrix A is equal to product of eigenvalues. So these two properties are very important for you. Check. Huh? Okay. Are you able to see? The PPT is not visible. This screen is okay now? Is it visible now? That's what somebody just now called me and said it's not coming. That's why I am asking you. Okay, thank you. Thank you. Somebody just now called me and told it's not coming. That's why I'm asking you. Okay. Okay, right. Thank you. Sorry for the disturbance. Right. So the next one is, consider the system of equations 1, 3, 2, 2, 2 minus 3, or 4, 4 minus 6, 2, 5 and 2. So the value of x3, because you have to eliminate some of the rows here, 2, 4. The second row and third row, see 2, 2 minus 3, 4, 4 minus 6. So multiply the second row with 2, you get the same thing. So this third row can be neglected. When you neglect the third row, then solve the system, you get x3. Yes, I am giving you hints so that you can do the problems, and you will get the practice if you do. If I solve the problems, you won't get the practice. Then if A and B are two n by n matrices, let rank of M and determinant of M denote the rank and determinant of the matrix respectively. Consider the following statements. Rank of A, B is equal to rank of A into rank of B. Determinant of A, B is equal to determinant of A into B. This is true. Rank of A into B, rank of A into B need not be true. It is not correct. But determinant of A into B is equal to determinant of A into B. This is true. Okay. So is there any other correct answer? Let us see. Rank of A plus B is less than or equal to rank of A plus rank of B. Because addition is there, you can have some relation. Why this is not true is A and B may be non-zero matrices, but their product may be zero. So this is absolutely not correct. Whereas 2 is right, 3 is right. So consider the following system of linear equations, so on and so forth, and which one of these statements are true whenever a solution exists for the system. So write the equations x1 plus 2x2 is equal to b1, so on and so forth. The equation is like this. If you apply row transformations, column transformations, you have to neglect some of the rows and then see rank of A is equal to rank of B. Then if you eliminate this, you get relation between B1 and B2. Largest eigenvalue of the matrix, better you solve the problems. 4 minus lambda, 1 minus lambda, 4 1 minus 2 1. 4 1 1 is the last element minus 2 1. Minus 2 1. So A minus lambda is 4 minus lambda 1 minus 2 1 minus lambda. Find the determinant of this, equal to 0. 4 minus lambda into 2 minus lambda 1 minus lambda plus 2 is equal to 0. This is 1. So if you find the roots, you will get this. Because 2 by 2 matrix, you can do it better. You solve the eigenvalues directly. This is 1 minus lambda. And you get the largest eigenvalue. So this is how you get a set of linear equations given in the form Ax is equal to B, where A is 2 by 4 matrix with real matrix B and B not equal to 0. 2 by 4 matrix. 2 rows and 4 columns. Will it be possible to solve for X and obtain unique solution by multiplying the obtained sides of this A transpose? Yes, we can obtain unique solution. This is a very wonderful problem. You have to use your logic and you have to see whether this is true. Yes, by multiplying with A transpose. What happens? Ax is equal to B, B not equal to 0. Multiply both sides with A transpose. So A transpose Ax is equal to A transpose B. Okay. We multiply with A transpose A on both sides, then A transpose A whole inverse into A transpose Ax is equal to A transpose A whole inverse into A transpose B. So this A inverse into this becomes A inverse A transpose inverse. So A transpose inverse into A transpose, that is I, and then A into A inverse. So Ix is equal to A transpose into A inverse A transpose B. So X is a 4 by 1. A transpose A is a 4 by 4. So its inverse is also 4 by 4. So this is 4 by 2. So we get 4 by 1 matrix. Directly it is not possible. But by multiplying with A transpose, you can do it. So it's a very good logical question. Okay. Then you have to work out. There is no shortcut for this. You have to work out the few steps that are given in the problem. Consider the matrix M is equal to 1 minus 1 0 1 minus 2 1 0 minus 1 1. One of the eigenvectors of M. So whether it is an eigenvector or not, I told you, multiply the matrix and the eigenvector. You have to get lambda into X. So this 1 minus 1 0 into first consider A. Finding the eigenvectors becomes very difficult thing because you have to find all the eigenvalues and then eigenvectors. That's a long process. The trick here is multiply the matrix with the eigenvector. So what you are getting? Minus 2, minus 4, minus 2. Is it a multiple of the eigenvector? No, because here all are ones. It is 2, 4, 2, minus 2, minus 4, minus 2. So it cannot be expressed as lambda times X. Can take the second one, 1 minus 1, 1. So m into x is like this. So if you have 2, 4, 2, but this vector is 1 minus 1. So it is not equal to lambda to x. You cannot find a lambda such that lambda x is equal to this one. And if you say 1, 1, 1, if you take, multiply this with 1, 1, 1, we are getting a 0, 0, 0. But 0, 0, 0, you can write it as 0 into this eigenvector x. That means m into x is equal to 0 into x again. So lambda is equal to 0 in eigenvalue. So this eigenvector 1, 1, 1 is the eigenvector out of all possibilities. So C is your correct answer. That I weigh 100-dimensional identity matrix. So 100 by 100 matrix. And E be the set of its distinct real eigenvalues. The number of elements in E is. So these are this is the diagonal elements. The eigenvalue of diagonal elements are always its diagonal elements. So eigenvalues are 1, 1, 1, 1. How many times? Repeated eigenvalue for 100 times. So E is equal to set of 1. So the set of eigenvalues becomes only 1 only. Though it comes 100 times, the set is always 1. So the number of elements in E is only 1. Our cardinal number of E is 1. The following system of equations has no solution. You have to find this because it's a homogeneous equation. See, when a homogeneous equation is given, there is nothing like we don't have a solution. It is always has a solution. It may be a zero solution or may be a non-zero solution. But there is no solution, it never happens. So this is never an option for a homogeneous equation. The homogeneous system of equations always has a solution, at least trivial solution. Okay, and unique solution is also only happens only when it is a trivial solution. So these two things are generally done. This is absolutely not possible. This is sometimes possible. That means whenever you have trivial solution. As three solutions, we cannot say two solutions or three solutions. Either you have unique solution, trivial solution, or infinite number of solutions. So D is the correct answer. You need not even solve this. See, what I want to say is, for this type of problems, don't try to solve the equation. Use the logic. You don't need to solve such problems. You need not solve this problem. It has no always. So we have always a solution for homogeneous system of equations. It's not possible. This is not possible. This is not possible. So we have infinite number of solutions. One of the eigenvalues of the following matrix is 1. What is the other eigenvalue? So find the eigenvalues because it is x. You have to get this value of x. Lambda must be equal to 1 is the root of this thing. You have to find. Next one is the inverse of a matrix 2, 3, 4. Now you people are saying problems are lengthy and tell me a shortcut. Now the inverse of the matrix is given to you in this exam, in this problem. So we have to use maybe standard method or maybe adjoint by determinant or maybe Gauss elimination, Gauss Jordan, whatever it is. You have to find this 2, 3, 4, 4, 3, 1, 1, 2, 4. But if you think that is difficult for you to find the inverse of matrix using those methods, do one thing. In a simpler way you can do. You multiply these matrices with this, with this, with this. Whenever you get an identity matrix, that is the inverse of the matrix. The property of a matrix inverse is A into A inverse is equal to I. Maybe because it is a matrix multiplication, you can find it easily. Multiply this matrix with each of these alternatives, one by one, or one after the other. Whenever you get I, that is inverse. System of n homogeneous linear equations containing n unknowns will have non-trivial solution if and only if determinant of the quotient matrix is 0. We have taken consider Ax is equal to 0. When determinant of A is not equal to 0, x always has a trivial solution. So non-trivial solution, determinant of A must be 0. The product of the eigenvalues of the matrix. So product is a determinant of the matrix. Product of the eigenvalues is determinant of the matrix. What determinant of the matrix? 2 into 7, 14 minus 0. So So it is given as 13.9 to 14.1, but actually it is 14. Let X be a square matrix. Consider the following two statements on X. So one, X is invertible. Two, determinant of X is non-zero. X be a square matrix, whichever one of the following is true. 1 implies 2, invertible does not imply determinant is non-zero. 2 implies 1, determinant of 0 is non-zero, but 1 does not imply 2, no. 1 does not imply 2, no. So 1 and 2 are equally statement. That means whenever determinant is non-zero, inverse exists. And whenever inverse is existing, determinant is not equal to 0. Both are equal statements. Consider the following matrix. The absolute value of the product of the eigenvalues. So, you need not find the eigenvalues. Once again, I am telling you, for such problems, very frequently you are getting the gate examination, you need not find the evaluate the eigenvalues. Is what is asking is product of the eigenvalues. So, find the determinant of the matrix. So, you need not worry. You subtract 1 from this will be 0. Then again use this to make this 0, and so on and so forth. You can reduce it echelon form, you will get the determinant easily. The number of distinct eigenvalues of the matrix. So this is a upper triangular matrix. An upper triangular and lower triangular matrix, the eigenvalues are the diagonal elements. So what are the eigenvalues? Lambda is equal to 2, 1, 3 and 2. Repeat, lambda is equal to 1, 3 and 2. What is the question? Number of distinct eigenvalues. How many distinct eigenvalues are there? Because 2 is repeating, it's not distinct. So 1, 2 and 3 are the distinct eigenvalues. 2 comes twice, so we don't count it twice. So 1, 2, 3 are the distinct eigenvalues. So answer is 3. So M is a 2 by 2 matrix with eigenvalues 4 and 9. The eigenvalues of M square, I told you no. If M is equal to 2 is an eigenvalue, what are the eigenvalues of M square? The eigenvalues of M square, if you don't read the properties, you cannot answer the question. So the eigenvalues of M square are lambda square. So 4 square and 9 square, 16 and 81 are the eigenvalues of M square. They are the questions in GATE. These are the type of questions we are getting in GATE. The rank of the matrix, simply you can find the determinant and find it. So this is also one nice question, logical question. M is equal to V1, V2, V1, U2 column vectors, and M inverse is U1 transpose, U1 transpose. So this you have to put it on paper and do it. Not a difficult one, you have to use the simple logic of what is V1 and V2, U1 and U2 and identity matrix. Consider the matrix P is equal to 1, 1, 0, 1, 1, 0, 0, 1. Number of distinct eigenvalues. Here also it is an upper triangular matrix. So for upper triangle matrix, what are the eigenvalues? Diagonal elements are the eigenvalues. So 1, 1, 1 are the eigenvalues. They are equal eigenvalues. Distinct means different eigenvalues. How many different eigenvalues we have? We have only one. So the answer is 1. The set of equation x plus y plus z is equal to 1. Ax minus ay plus 3z is equal to 5. 5x minus 3y. So the equations are x plus matrix is 1, 1, 1, a minus a3, 5 minus 3, a. Near 1, 5, 6. So if you work out this problem, the matrix is 1, 1, 1, a minus a 3, 5 minus 3, a. This is what we are calling augmented matrix. Okay, the question now is, as infinite number of solutions, when do we have infinite number of solutions? The rule is rank of A given A augmented with B must be rank of A is equal to, if it is R, then it must be less than number of unknowns. N is 3 here. So whenever rank is less than 3, we have infinite number of solutions. This is the logic. So now we have to obtain this as R1 R2 minus A times R1. So multiply the first row with A1 and subtract the second row. The first row remains the same, 1. This will be 0 because A minus A into 1. This is minus A minus minus 2A. This is 3 minus A. This 6. This is 5 minus A. The last row also you consider this R3 minus 5 R1. So this element becomes 0. Minus 3 minus 5 minus 8 and A minus 5. This will be 6 minus 5 1. So the rank must be less than 3. So determinant must be some of the rows may be equal. So when the second row and third row, let us say if they are equal, minus 2A is equal to minus A implies A is equal to 4. Let us see what happens to other statement also. 3 minus A, what happens to 3 minus A? Is equal to A minus 5 implies 2A is equal to 8 or A is equal to 4. And whatever this element, this 5 minus 4 is 1, 1. So if we put A is equal to 4, what happens here? 1, 1, 1, 1. This element is 0, minus 8, minus 1, 1. This will be minus 8, 0, minus 8. This is A minus 5, minus 1. This is 1. So let us see this. This row becomes completely 0. So you have 3 unknowns. So rank of, as I said, rank of A is 2 less than 3. So we have infinite number of solutions. This is how, using this matrix, you have to apply some transformations and find the value of A. Okay, so C is 4, answer is 4. So in matrix equation Ax is equal to R, one of the eigenvalues of matrix here. Ax is equal to R. So this R, I said Ax is equal to lambda x. If you can write this R as lambda times 2 and 4. So this is 2, 1, 4, this is 32, 16, 64. If let us say if you 16 2s are 32, 16 1s are 16, 16 4s are 64. So from this R you can take 16 common, then becomes 2, 1, 4. So this Ax is equal to 16 times x. So what is the eigenvalue? 16. The transformation matrix for mirroring a point xy plane about y-axis is given by this one, because cos x and sin x are equal. This is what we get here. Lambda 1 and lambda 2 eigenvalues of matrix A, 0, minus 1, 1, 1, and lambda 1 plus lambda 2 and lambda 1 lambda 2. Again the same. See how many questions we are getting on the same property. Sum of the eigenvalues and product of the eigenvalues. Till now we have done 4 or 5 problems in GATE. Every year we have one problem on sum of the eigenvalues and product of the eigenvalues. So sum of the eigenvalues is sum of the principal elements, that is 1. Product is trace is 1. 1 and 1. You need not to, just by looking at this you can tell the answer. A is equal to 1, 2, 2, 1, x is equal to 1, A, B, 0, y is equal to 3, 1, 3, 2, x is equal to y, then A plus B becomes. So we simply have to solve it. Multiply these two things, you will get A and B. System of equations, P and Q are constant, x1 plus x1 plus x2 3 is equal to 1, x1 minus 2x2 plus 2x3 is equal to P, 3x1 minus x2 plus 5x3 is equal to P. To construct this argument matrix just with the way we did, okay, the system is at least one solution. That means determinant of A is not equal to 0. If you apply this principle, you get the condition here. Next one is 2018 questions. Which of the following matrices singular matrices? Find the determinants. Which one is not equal to 0? Which one is equal to 0? That becomes a singular matrix. For the given orthogonal matrix, the inverse C. This is one more nice question. The property of orthogonal matrix. What is the orthogonal matrix? If A is equal to A transpose is equal to A inverse. A into A transpose is equal to I. Either way you can say. That will be your orthogonal matrix. So this is orthogonal matrix. The property of orthogonal matrix is A transpose is equal to or A inverse is equal to A transpose. This is A or Q. Q inverse is equal to Q transpose. If you want to find this, transpose this matrix because it is orthogonal matrix. What is the transpose here? 3 by 7 minus 6 by 7, 2 by 7. See where is our option? 3 by 7 minus 6 by C. Let us see the option C. 3 by 7 minus 6 by 7, 2 by 7. 3 by 7 minus 6 by 7, 2 by 7, 2 by 7, 3 by 7, 6 by 7, 6 by 7, 2 by 7 minus 3 by 7. So option is C. So what is the property there? Q is orthogonal matrix, then Q into Q transpose is equal to identity matrix, or Q inverse is equal to Q transpose. The matrix 2 minus 4, 4, 2 has 3 eigenvalues, eigenvectors. Find out the eigenvalues, that's better because a 2 by 2 matrix very easily can solve it. The rank of the following matrix. So we have to apply row transformations and column transformations carefully. Then we get that. For the matrix A, cos theta minus sin theta, cos theta, determinant stands determinant of A transpose A. Yeah, I can find it. Unit matrix you get. So similar problem. U transpose V, U into V transpose. I have multiply this U into V transpose and then find largest eigen. If you multiply these two things, U into V transpose, you get a 2 by 2 matrix. Find the eigenvalues of that matrix. Consider matrix P whose eigenvectors are the multiples of 1 by 4. Consider matrix P whose only eigenvectors are multiples of 1 by 4. And the 1 by 4 is the only independent eigenvector. Okay. So that means repeated eigenvalues. So P has repeated eigenvalue. P cannot be diagonalized. Which of the following is true? 2 and 3 are necessarily true. We cannot talk about the inverse. Whether it is inverse, whether it exists or not. We can say whenever repeated eigenvectors are there, we get scalar multiples of 1 by 4. We have repeated eigenvalues and P cannot be diagonalized. So these are the previous questions we have from this linear algebra part. And let us deal some more problems from some multiple choice questions. Yesterday we have done some problems already, but we have done the basic algebra. Now we have to see some more problems on eigenvalues and eigenvectors. If 1, 2, 3 are the latent roots of the square matrix, I said latent roots, don't get confused. Latent means eigenvalues. I told you already, other names for eigenvalues are characteristic roots or characteristic values or latent roots or latent values, eigenvalues or eigenroots. We have 5, 6 different ways of calling this. If 1, 2, 3 are the latent roots of a square matrix A, then the latent roots of A square, again I said, when I say lambda power n is a eigenvalue of A power n. So then the squares of these are the roots, eigenvalues of this A square. So if you square then 1, 4 and 9 are the eigenvalues of this A square. The diagonal matrix has eigenvalues of A as its elements. Positive values, real values, diagonal or spectral. So diagonal matrix eigenvalues are all the diagonal elements are the eigenvalues. The matrix B which diagonals A is called is matrix a model matrix. The eigenvalues of A and A transpose, this is also standard principle. The eigenvalues of A and A transpose are same. The eigenvalues of unit matrix of order 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. So obviously diagonal elements are the eigenvalues. Product of the eigenvalues of matrix is equal to determinant of the matrix. If one eigenvalue of A is 0, then A is, yesterday we have discussed this point in fact some time back. If one eigenvalue of A is 0, then what happens to A? See, the property is, if lambda is an eigenvalue of A, then 1 by lambda is an eigenvalue of A inverse. But if lambda is 0, what happens to 1 by lambda? It goes to infinity. First thing. Second thing, the equation is determinant of A minus lambda is equal to 0. If 0 is an eigenvalue lambda, put the lambda is equal to 0 in the equation, then determinant of A minus lambda becomes determinant of A is equal to 0. What does it mean? Determinant of A is equal to 0 is singular matrix. Singular, non-singular, symmetric, non-symmetric. Option is A. Lambda 1, lambda 2, lambda 3, the eigenvalues of matrix A. Then 1 by lambda 1, 1 by lambda 2, as I said just now, A inverse. If A and B are square matrices at AB, square matrices and AB non-singular. It's not AB. A is a non-singular. Then AB and B into A inverse. I have seen it should be actually this spelled wrong. Is A inverse B into B and B into A inverse. This is A into B inverse. If A is a singular matrix, then the eigenvalues. If A is a triangular matrix, then the eigenvalues are diagonal elements. The eigenvalues of real symmetric matrix. These are the basic principles. The symmetric part, the two eigenvectors of symmetric matrix, then the eigenvector third element is 1, 2, 5. They are all based on the properties only. Straight away we'll get these two questions you need not consider because we need not go through this because this is this one and this one, 16 and 18, because they deal with quadratic forms. We don't have that in the syllabus. So key is also given. There are some other questions on matrices. So with this we come to close this matrices are linear algebra. So till now what we have completed in GATE syllabus is the common topics we have completed, calculus is completed, and then linear algebra is completed. The other common topics we have is differential equations. The next one, that is the biggest one, ordinary differential equations and partial differential equations. Now we will go to ordinary differential equations. So here onwards I will be using my pad to explain you, okay, and we will get a PDF also of my notes written on digital pad. So ordinary differential equation. So what is an ordinary differential equation? Okay. An equation involving the dependent variable and its derivatives and independent variable is called a differential equation. That means if y is equal to f of x, if y is a dependent variable, x is independent variable, then a relation connecting x, y, y dash, y double dash, so on and so forth, and the derivatives is equal to 0 is called a differential equation. So by looking at a differential equation, the basic properties that we have to identify, very important properties, are order of a differential equation and degree of a differential equation. What is the order of the differential equation? The order of the highest derivative present in the differential equation. What is the highest derivative present in the given differential equation? You observe that highest derivative and what is the order of the highest derivative. So for example, d square by dx square plus x into dy by dx plus y is equal to e power minus x. This is a differential equation. That means a relation involving the dependent variable, independent variable and the higher order derivatives. So higher order derivative that we see here is d square y by dx square. So the order is because the second order derivative order is 2. So for example, x y triple dash minus y double dash plus x minus y into y dash plus y is equal to e power x. If we observe the equation, highest derivative here is y triple dash, y3. So 3 is your order of the differential equation. You don't have any confusion in fact here, but while dealing with degree you have to be more careful. What is degree then? It is the highest degree of highest derivative after the differential equation is made free of radicals and fractions as far as the derivatives are concerned. See here in this equation, the highest derivative or dy by dx, they are the derivative terms. They don't have power 1 by 2, power 1 by 3, something like this. They are free. Even if there is something there, for the order is not an issue. For the highest degree, after making the differential equation free of radicals and fractions, say for example, if you consider equation like y is equal to x y dash plus cube root of 1 plus y double dash square. This is what we call the highlighted part, is what we call radical or fractionals. And point is, after the dg is made, I use this dg means stands for differential equation. The differential equation is made free of radicals and fractions as far as the derivatives are concerned. So you have to eliminate these square roots and cube roots, so on and so forth. How do you make them? So you send this x y dash to the other side. So y minus x y dash becomes a cube root raised to the power of cube. So y minus x y dash whole cube is equal to 1 plus y double dash whole square. Now the equation is free of radicals and fractions. So now what is the highest derivative? Y double dash. Y double dash. Statement is the highest degree of highest derivative, the power of the highest derivative. So y double dash is the highest derivative. What is the power of that? 2. So degree of the differential equation is 2. So another example, y double dash is equal to 1 plus y1 square whole power 3 by 2. Yes, again we have a fraction here. We have to eliminate this. How do you eliminate this? By squaring both sides. Y double dash square is equal to 1 plus y dash square whole cube. What is the highest derivative in this? Y double dash. What is the power of that? 2. So that is your degree of differential equation. What is the order of this equation? Highest order derivative is 2. So this is a second order, second degree differential equation. Okay. Then once this is known, then how do you classify? How do you find the solutions of differential equation? What is the solution of a differential equation? A relation between the dependent variable and the independent variable, and it should not have derivatives. It should not have the derivatives. Then such a relation between the independent variable and dependent variable is called a solution of the differential equation. So a general solution. A solution difference between there is a difference between solution and general solution, because solution can be a particular solution. But general solution is a solution which contains some arbitrary constants. I told you the importance of arbitrary constants in the very first class. If I say y is equal to x, it is a straight line. But if I say y is equal to mx and m is arbitrary constant, then m can take any value on the real line from minus infinity to plus infinity. So m is equal to 0, x-axis. Y is equal to mx becomes 0. If you take y is equal to 1, y is equal to x. If you take y is equal to 2, y is equal to x. Y is equal to 3x, y is equal to 4x. So if you go on changing the values of the arbitrary constant, you have infinite number of straight lines passing through origin. So the general solution is one which contains arbitrary constants. If you go on changing the values of arbitrary constant, we get different curves, and those curves are called family of curves. We have discussed in the first class. So general solution of a differential equation, physically it represents a family of curves. So, and then if you find a general solution of a differential equations, how many arbitrary constants will be there? That is also one important issue. Number of arbitrary constants in the general solution is equal to order of the differential equation. If you take a second order equation, we have two arbitrary constants. We have 10th order differential equation, we have 10 arbitrary constants. Then how do you form differential equations? Where from we get these differential equations? Differential equations, see, this general solution and formulate differential equation, they are interlinked. Okay, this general solution contains arbitrary constants. From this general solution, if you eliminate the arbitrary constants, you get differential equations. And if you solve the differential equation, you will get a general solution involving arbitrary constants. From this general solution, you get differential equation. If you solve differential equation, we get general solution. They are always from one from the other. These differential equations are obtained from general solution. General solutions are obtained from differential equations. Differential equations are obtained by eliminating arbitrary constants from the general relation of the form phi of xy c1 c2 cn is equal to 0. Here how many constants we have? c1 c2 cn. So there are n constant. By differentiating this function n times, we eliminate n constants. So when we differentiate this with n times, we get nth order differential equation. Example, y is equal to a into cos nt plus c. What is the differential equation corresponding to these equations? So a and c are arbitrary constants to be eliminated. So how many constants we have? A and c, two constants. So how many times we have to differentiate? As per this principle, number of arbitrary constants in solution order of the differential equation, and there are n constant and differentiating n times. That's what we get. So first time if you differentiate with respect to t, y dash is dy by dt is equal to a into derivative of cos nt plus c is minus a sin nt plus c, and derivative of nt is n. So minus a n into sin nt plus c. If you differentiate again, so y double dash is equal to minus a n into derivative of sin nt plus c. So cos nt plus c into n. So it becomes minus a n square cos nt plus c. But what is a cos nt plus c? This is y. So this you can write as minus n square times y, and the equation is y double dash plus n square y is equal to 0. Do you know what is this equation? This is a simple harmonic equation. Y double dash plus n square y is wave equation, simple harmonic motion equation. Write the differential equation obtained by eliminating a and b from this equation. So again a and b we have two constants. To eliminate these two constants, we need to differentiate twice. So y dash is equal to a e power t. The derivative of this is minus b e power minus t. Again if you differentiate, y double dash is equal to a e power t plus b e power minus t. But a e power t plus b e power minus t is nothing but y. So y double dash is equal to y. Y double dash minus y is equal to 0 is the differential equation. Another example, if y is equal to a e power minus t plus b into e power minus 3t. Sometimes it's not that easy by using our simple substitution as we did in the previous problems. Then we have to, for elimination, we have to take the determinant, help of determinants also. So y is equal to a e power minus t plus b e power minus 3t. Because we have two constants, we have to differentiate twice. So y dash is minus a e power minus t minus 3b e power minus 3t. Y double dash is a e power minus t plus 9b e power minus 3t. This is what we get. So to eliminate this, use this y dash, y double dash. From this, eliminate b, a and b, like the coefficients are e power minus t, e power minus 3t. On the other side we have minus y. If you bring this to this side, minus y. And from this we have minus e power minus t, coefficient of a, coefficient of b is minus 3 e power minus 3t, and other independent of t term is minus y dash. And similarly here, e power minus t, 9 e power minus 3t, and minus y double dash are this thing. If you find the determinant, you get a relation between y dash, and y double dash. That will be your differential equation after eliminating a and b from this y. Another example, y is equal to cx plus c minus c cube. So we have only one arbitrary constant, one derivative is enough. So if we differentiate this, y dash is equal to c, they are constant, so derivative becomes 0. So if we replace c in the equation, y is equal to x into y dash plus y dash minus y dash cube. Okay. So ax square plus by square is equal to 1. differentiate with respect to x. So because two constants we have differentiate twice, 2ax plus 2by into y dash is 0. Differentiate again with respect to x, it becomes 2a plus 2b into u into v rule, y into y double dash plus y dash into y dash square is equal to 0. Now, if you eliminate a and b, the first one is a, b, 1. My quotient of a and b are x square, y square, 1. The second equation, quotient of x is a is 2x. I'm sorry, 2 cancel 2 is 2a, 2, 0, no? You cancel 2 throughout. So, quotient of a is x, quotient of b is y dash. Other side we have 0. Third equation, what we have? Here also you can cancel 2. So, 1, the quotient of b is y double dash plus y1 square and 0. You find the determinant about this point, this column 1 into x into y double dash plus y1 square minus y dash. This is the differential equation of eliminating a and b from the given function. Now, solutions of first order and first degree differential equation. We have seen what is order of the equation, what is the other important basic principles of a differential equation, and then formation of differential equation. Now, we see how to find the solutions of first order, first degree differential equations. So, first order, first degree differential equation, the standard form is of the form dy by dx is equal to f of xy. So, there are several methods to find the solution of this equation. So, one of the basic methods is the methods depend on the structure of this f of the function f of xy. So, depending on the structure of the functions, the differential equations of first order and first degree are classified in different ways. One is the first and basic method is variable separable. The second one is linear and Bernoulli's equation. In between there is one more form that is called homogeneous equations, but those equations are a bit very lengthy. Anyhow, those equations can be homogeneous equations can be solved using exact and reducible exact form also. That's why I'm not discussing that in my discussion. So our basic discussions are variable separable, linear and Bernoulli, and exact and reducible to exact equations. So then what is the variable separable method here? Again, as said, it depends on the function. If dy by dx is equal to f of x into g of y, that means the f of xy is of the form, so I should not write f here, I write g into h, nothing matter. If dy by dx is equal to f of x into g of y or f of x by g of y, that means terms of x can be separated from terms of y. Terms of x can be separated from terms of y. Then such an equation is called said to be in variable separable form. Such a differential equation is said to be in variable separable form. So then what happens if you take this dy by dx is equal to f of x by g of y, cross multiply. So g of y into dy is equal to f of x into dx. We integrate g of y dy is equal to integral f of x dx plus some integral constancy. This is what we call variable separable method. Very basic and very simple method, but you have to observe the terms closely. Then you can use it, you can do it more comfortably. So what are the terms that can be separated that we have to observe? So first problem is dy by dx is equal to e power 3x or e power 3x minus 2y plus x square into e power minus 2y. So in both the terms, what is the term that is common? E power minus 2y is here, e power minus 2y is there. So if you send this e power minus 2y to the other side, what happens? E power 2y dy is equal to e power 3x plus x square into dx. So functions of y are separated from functions of x. So straight away now, if you integrate this, integrate e power 2y dy plus 2 is equal to e power 3x by 3 plus x cube by 3 plus constant. That is your solution. Okay. Next problem is y minus 3x into dx plus x plus xy into dy is equal to 0. So if you take y common here, y into 1 minus x dx plus x into 1 plus y dy. Really, if you do multiply with xy on both sides, we divide by xy. So y gets cancelled, 1 minus x by x dx plus 1 plus y by y dy is equal to 0. So clearly the functions of x are eliminated from functions of y. So this is nothing but 1 by x minus 1 dx. This is 1 by y plus 1 dy is equal to c. We integrate to get a solution. This is about variable separable method. The second important linear equations are very important, and we are getting many questions from these linear equations to find the integrative factor of this linear equation. Directly we are getting questions on this. So the linear equation is the form dy by dx plus p of x into y is equal to q of x. dy by dx plus p of x into y. So remember the form, standard form. This is a standard form. You have to remember it well. dy by dx plus p of x into y is equal to q of x. Working rule for this. You have to find an integrating factor. Integrating factor is generally denoted by IF, integrating factor. It is given by, for this linear equation, e power integral p of x dx. Whatever p you have, the quotient of y, that you take, integrate with respect to x, and that function, the power of exponential function of that, it gives integrating factor, e power integral p of x dx. So once you get the integrating factor, then the solution is given by y into integrating factor is equal to integral of this qx into integral factor dx. Let's see. I explain the terms once again. Once you find the integrating factor, the solution is given by y into integrating factor is equal to integral of qx. Qx is the function on the right hand side into integrating factor dx plus c. This is the solution. Sometimes what happens is the equation may not, it is very difficult sometimes to convert the equation into dy by dx. See, the equation need not be always in this form, maybe in a different form. If it is not possible to convert that equation into this form, or it is convenient to convert the equation into like this. The only difference between these, here we have dy by dx plus pxy. And here maybe sometimes dx by dy plus py into x. Okay. Completely the other type of this thing, linear equation. Here dy by dx plus p of x into y. Here dx by dy plus p of y into x is equal to p of y. Then the similar way, the integrating factor is given by here function p of y into e power integral p of y dy. That will be your integrating factor. Once you have the integrating factor, just like in the previous case, in place of x, y we have x. So x into integrating factor is equal to q of y into integrating factor dy plus c. This is the solution for the given problem. This is called linear equation. Now let us see what is the examples, some examples for these linear equations. X divided by dx plus y is equal to log x. Whenever problem is given to you, we always try to convert into linear equation. So for the first step, we have to make the coefficient of divided by x is equal to 1. So divide throughout by x. So y dash plus, so sometimes I use y dash also for simplicity. So what happens is y dash plus y by x plus log x by x. So this is in the standard form. What is px? Quotient of y is 1 by x. Px is log x by x. So integrating factor is in the standard form. So integrating factor is e power integral p of x ds, e power integral 1 by x dx. Integral 1 by x dx is log x. So e power log x. So e power log x is x. So what is integrating factor? X. The solution is given by y into integrating factor. So integrating factor is x. So y into integrating factor is equal to integral q into integrating factor. What is q here? Log x. Log x by x. Sorry, this is the thing. Log x by x into x, q of x into integrating factor dx. X gets cancelled. Integral log x plus c. So integral log x plus c is x into log x minus 1 plus c. This is what we get. The solution. So another problem, y dash minus 2y by x plus 1 is equal to x plus 1 more. This is the standard form directly. Okay. So p of x is minus 2 by x plus 1. The coefficient of y in the equation. So integrated factor will be e power integral p dx. Integral p dx means minus integral 2 by x plus 1 dx. So 2 by x plus 1 integral is 2 log 1 by x plus 1. Because minus sign is there, this is actually 2 log x plus 1, but minus is there. So 2 log 1 by x plus 1 or 1 by x plus 1 whole square. So solution is y into integrating factor, y into 1 by x plus 1 whole square is equal to q. What is q? X plus 1 whole cube into integrating factor. So you cancel this cube and x plus 1 whole square. So integral x plus 1 is x plus 1 whole square by 2 plus constant. That is the solution. So y is equal to, if you take this x plus 1 whole square to the other side, x plus 1 power 4 by 2 plus c into x plus 1 whole square. Another problem. Now it's not the standard problem. 1 plus y square into dx is equal to tan inverse y minus x times dy. So if you try to convert the standard form as dy by dx, the terms will not be compatible with the method. We cannot do it easily. So what we do is, the best way is we write the equation in terms of dx by dy. That means second form. So dx by dy is equal to, so we divide throughout with divide by dy, dx by dy is and 1 plus y square divided by 1 plus y square. So tan inverse y by 1 plus y square minus x by 1 plus x square, bring it to the side. Dx by dy plus x by 1 plus y square is equal to tan inverse y by 1 plus y square. This is in the form dx by dy is equal to p of y into x is equal to p of y. So it's the second standard form. So in this case, integrating factor is e power integral p y dy like this. This one. So integrating factor is integral e power integral p of y dy. What is p of y? 1 by 1 plus y square. So integral of 1 by 1 plus y square is tan inverse y. So integrating factor becomes e power tan inverse y. E power tan inverse y. So the solution is x into integrating factor, that means x into e power tan inverse y is equal to q of y. What is q of y? Tan inverse y by 1 plus y square into e power tan inverse y dy plus. So if you put tan inverse y is equal to t, 1 by 1 plus y square dy is equal to t dt. So this will dy by 1 plus y square, this term will be dt. This is t and e power t dt. So if we integrate this, we get substitute tan inverse y. So one more problem. Find the integrating factor for the differential equation. What is the integrating factor? dy by dx plus y by x log x is equal to sin 2x by log x. So it's the standard problem, dy by dx plus p of x into y is equal to p of x. What is p? 1 by x log x. So integrating factor is e power integral 1 by x log x. If you put log x is equal to t, 1 by x dx becomes dt. So this becomes 1 by x dx is, this is dt. dt by log x is dt by t. Or else e power log t, or t is equal to t. But t is log x. So integrating factor is log x. So the solution now, you can find, multiply this with y into log x is equal to so on and so forth. That's what we get the solution from. Just I'm asking you what is integrating factor for this. The integrating factor for y dash plus 2x by 1 plus y square into y is equal to 1 by x square plus 1 whole square. Again, it's in the standard form. dy by dx plus p of x into y is equal to p of x, where p of x is 3x by 1 plus x square. So integrating factor is e power integral p dx. So e power integral 2x by 1 plus x square dx. So if you put 1 plus x square is equal to t, then 2x dx is dt. So this becomes integral dt by t. So e power integral dt by dt is log t. So this integrating factor is e power log t or simply t. What is t? Plus x square. So the solution is y into integrating factor, that is 1 plus x square, is equal to q. What is q? 1 by x square plus 1 whole square into integrating factor, that is 1 plus x square dx plus c. You can cancel this 1 plus x square once here. So we'll be left with 1 by x square plus 1 dx. What is integral of 1 by 1 plus x square? Tan inverse x. So this is tan inverse x plus c is equal to y into 1 plus x square. So our y is equal to, we get this y from this. So this is about linear equations. Coming to the Bernoulli's equation. It is a more general version of linear equation. An equation of the form dy by dx plus p of y. In this part we have same expression, dy by dx plus p of x into y. Till then we have same thing as linear equation. The difference is on the right hand side we get q into y power n. Q into y power n. It is called Bernoulli's equation. We should not understand problem. Standard problem is on the right hand side only we have function of x, that is q of x, nothing else. But here we have another term, that is y power n. So whenever we have y power n and we have to reduce it to the standard form. So for that we divide throughout by y power minus n. Don't think this is a procedure. Sometimes it may not be in terms of y power n. It may be some other function of y. Then what to do? You have to multiply, divide throughout that term. You have to see the procedure here, because for the other problems you have to apply this. So if you divide throughout by y power n, then y power minus n y dash plus p into y by y power n, that is y power 1 minus n, is equal to q. So if you put this y power minus n, y power 1 minus n is equal to t. If you differentiate this, 1 minus n into y power 1 minus n minus 1, that is y power minus n, into y dash is equal to t dash. Okay, so if you substitute these things here in this equation, dy by dt is 1 by 1 minus n into y power minus n dt by dt. So substitute these things in this equation. We get 1 minus n into t dash plus p of t is equal to q, or t dash plus, you multiply throughout with 1 minus n, t dash plus 1 minus n into pt is equal to 1 minus n into q. Now it is in the standard form, because 1 minus n is a constant, it matters nothing for us, it's not a big deal. So this is the standard problem, dt by dx plus 1 minus n into t into p is equal to q of t. So this is the standard form, and integrating factor is e power integral p dx. P is here 1 minus n into t. So sorry, 1 minus n into p. So e power integral 1 minus n into p, if you integrate, this is what we get. This is the solution now. So deal with some problems, let us deal. X into y dash plus y is equal to x cube into y power 4. This is the first problem. So to divide throughout with this equation is y dash plus y by x is equal to x square y power 4. So if we compare with the standard equation dy by dx plus p of x into y, till then same thing, x cube y power 4. The actual standard form We have only p of x, not q of x into y power n. That's the problem. So divide throughout first with y power 4 and then put y power minus 3 is equal to t, so on and so forth. This is what we get the solution. What is the solution of y dash plus y cos x is equal to y cube sin 2x? On the right hand side, we have a function of y that has to be eliminated. So divide through it with y cube. So what we get? 1 by y cube into y dash plus y by y cube, that means 1 by y square into cos x is equal to sin 2x. So if you put 1 by y square, this is equal to some t, and differentiate minus 2 by y cube y dash is equal to t dash. Okay. So y dash by y cube, that means this term, it can be equal to minus 1 by 2 t dash. We substitute here 1 by y cube y dash is minus 1 by 2 t dash plus 1 by y square is t into cos x is equal to sin 2x. So this is further it can be expressed as t dash minus 2t cos x minus 2 sin 2x. So px here is e power minus 2 cos x and qx is e power minus 2 sin 2x. So integrating factor is e power integral p of x dx. So integral e power integral minus 2 cos x dx. This is e power minus 2 sin x. So the solution is t into p of x is equal to integral q into q of x, that is sin 2x into e power minus 2. So this is what we get. Equations reducible to exact equations. Equations reducible to exact equations. So sometimes it need not be functions of, see here, we have seen y cube here. Here also something y power 4. Here also in the standard form also we are considering on the right hand side y power n. It need not be always a function y power n. Sometimes it can be functions also. Let us see how it comes. Okay. So y dash plus x into sin y dash plus x into sin 2y is equal to x cube into cos square y. X cube into cos square y. So we have to on the right hand side first eliminate this cos square y by dividing throughout. When you divide throughout, you get 1 by cos square y, that is secant square y into y dash plus x sin 2y. Sin 2y is 2 sin y cos y by cos square y. Can cancel the cos y in numerator denominator. So in the numerator we will be left with 2 sin y divided by cos y. So that is 2 tan y into x is equal to x cube. So now if you put tan y, still is not in the standard form. If you put tan y is equal to t, then secant square y into y dash is t dash. So the secant square y dash becomes t dash. This equation now becomes t dash plus 2 into what is tan y? Tan y is t into x. T dash plus 2tx plus t cube. It is in the standard form y dash plus p of x into y is equal to q of x. So integrating factor is e power p is 2x e power x cube e power x square. So multiply throughout, the solution is t into integrating factor is equal to q of x, that is x cube into integrating factor e power x square. So this is how we get the solution for the equation. And the example, x square y dash is equal to e power y minus x. So divide throughout by x square, y dash is equal to e power y by x square minus 1 by x, or else e power minus y dash is equal to 1 by x square minus e power minus y by x. So bring to the side, e power minus y dash is plus e power minus y by x is equal to 1 by x square. So put e power minus y is equal to t. So e power minus y dy is equal to d dash by ex, or t dash. So this equation now becomes minus t dash plus t by x is equal to 1 by x square, or t dash minus t by x is equal to minus 1 by x square, in which p of x is minus 1 by x. So integrating factor is e power minus integral 1 by x dx, that is e power minus log x or e power log 1 by x, that comes out to be 1 by x. So solution is t into, this is the equation, t into integrating factor is equal to integral of q into integrating factor 1 by x. This is how we get the equation. So if you see, go back to the three different forms of differential equations. Classification: variable separable, linear and Bernoulli equations, exact and reducible form. So variable separable we have done this, we have seen this. What is linear and Bernoulli equations? We have seen this. Now we have exact differential equations. What is so exact about this exact differential equations? Let us see. Let write the given differential equation in the form m of xy into x plus n into x of y dy. Mx dy dx plus nxy dy is equal to 0. It's clearly a first order differential equation, first degree differential equation. Why? Because we don't have any terms like dy by d square by dx square or dy by dx whole square, something like that. It's a simple first order first degree differential equation. And this equation is called exact if we can find a function f such that dou m by dou x is equal to dou m by dou y. This is an important condition. And again, once again, I am telling you, in theoretical problems, the standard bits can be asked like this. Mdx plus ndy is equal to 0 is called exact differential equation if m and n are exact derivatives. Dou f by dou x is, if you can find a function f such that dou f by dou x is equal to m, dou f by dou y is equal to n, and another two options can be anything. So for such problems you have to write m is equal to f by dou x and n is equal to dou f by dou y. This is the definition of exact differential equation. Now, so we have in the examination the problem is given to you m of x by dx plus n of x by dy is equal to 0. How to know whether this equation is exact or not? That is the question. Okay. What are the conditions for exactness? If m and n are real valued functions having continuous partial derivatives, then a necessary and sufficient condition for m dx plus n dy is equal to 0 to be exact is dou m by dou y is equal to dou n by dou x. So testing condition, what is the testing condition? If m dx plus n dy is equal to 0, we want to test the exactness of the differential equation or whether it is exact differential equation or not. So find this dou m by dou y. What is m? Quotient of x. What is n? Quotient of y. Sometimes to confuse you, the problem will be given as 2x plus y into dy plus 3x plus y into dx. So in general, our mentality is the first term partial derivative with respect to y, the second term partial derivative with respect to x. No, it's not the understanding. The coefficient of dx, the partial derivative with respect to y of the coefficient of dx. Okay, coefficient of dx with respect to y should be differential with respect to y. Coefficient of dy should be differential with respect to x. Be very careful with this. Sometimes dy term will be given first and then dx term. Then whatever you do, that will go wrong. Be very careful. It is read like coefficient of dx is m, coefficient of dy is n. Then dou m by dou y is equal to dou n by dou x. That is the testing condition for exactness of a differential equation. Let us say, good, it's an exact differential equation. Then what is the solution of the equation? That's what is required. So I don't give all the theoretical aspects and proof and all that. I give straight away the method to find the solution. Once it is differential equation, the terms of n do not contain x. So terms of x in n, terms in n which do not contain the terms of x. That means you have to pick up those terms which are independent of x, which don't involve x. Only those terms you have to integrate here with respect to y. Be very careful. I repeat it. Integral m dx, where m is treated as constant, and integral of n terms not containing x with respect to y is equal to c. That is the solution. Let us see how we derive we find the solutions of some simple problems. The first equation is y square minus 2xy dx plus 2xy minus x square dy. So what is m and n? On this side I have written m and n. M is equal to y square minus 2xy. And n is equal to 2xy minus x square. So you have to check this condition. So you cannot apply this formula if this is not satisfied. If this is satisfied and if the equation is exact, then you can apply the formula. So what is for this, to check this condition, what is m sub y means dou m by dou y is 2y minus 2x. N is 2xy minus x square. So dou n by dou x is 2y minus 2x. What are they? 2y minus 2x and 2y minus 2x. So dou m by dou y is equal to dou m by dou y. The condition is satisfied. So this is an exact differential equation. Then coming to the solution. What is the coming to the solution? What is the formula? Integral m dx, assuming y as constant, integral of terms of n which are independent of x. Integral of terms of n which are independent of x, and the integration should be done with respect to y. So what are the terms without x? We have x in the first term, we have x in the second, so we have 0 here, 0 terms. There is no term independent of x, so 0. So simply integrate this with respect to x, assuming y as constant. So y square x minus x square y is equal to, this is a very simple straight formula. Only thing you have to check this condition, and dou m by dou y is equal to dou m by dou x. Check the exactness of 2xy. Maybe it may be asked as, is the equation is exact? Yes, no. You cannot say exact but linear, linear but discuss the nature of the differential equation. A, option A, exact. B, linear, linear but not exact. Exact but not linear. Maybe different options. We have to pick out the right options for this. So check the exactness of 2xy minus 3xy dy minus x square y square minus 1 dx. So this is m is here. That's what I'm saying. Yes. Here, just by looking at this, you people write m as 2xy, n as this one. No, you go wrong. What is m? M is the coefficient of dx. Okay. So keep an eye on that. In which way, in which order the terms are given. M is the coefficient of dx. Okay. So m is, if you take minus inside, y square minus x square plus 1. So dou m by dou y is 2y. And what is n? 2xy dy. So dou n by dou x is 2y. So here also 2y, here also 2y. So dou m by dou y is equal to dou n by dou x. So equation is exact. So solution is integral of terms of m, assuming y as constant, y square minus x square plus 1. Plus integral of terms independent of x. Here again, what is n? 2xy. Is there anything independent of x? No. So 0. So the integral of this m with respect to x, that is the solution. So dy by dx plus y cos x plus sin y plus y by sin x plus x cos y plus x is y cos x plus sin y plus y into dx plus sin x plus x cos y plus x into dy is equal to 0. So m is this one, n is this one. So whenever given, so in equations, problems like this, first write dx term first and then dy term, then you will not commit mistake. This order should be maintained. So this is m, this is dou m by dou y is cos x plus derivative of sin y is cos y, derivative of y is 1, and nx is cos x plus cos y plus 1. Cos x plus cos y plus 1, cos x plus cos, they are equal. So hence this is exact equation. So the integral of the terms here with respect to x, assuming y as constant, and here also see again dy. I know you are very fortunate, all the problems we are getting zeros here. So if you is there anything which is independent of x, we have sin x here, x here, x here, now 0. Reduce only exact form. So once you have an exact equations, that is dou m by dou y is equal to dou n by dou x, you can find the integral using the formula. When the equation is not exact, then try to convert this equation into exact equation. How? So when dou m by dou y is equal to dou n by dou x, the equation is not exact, then we try to convert it into the exact form. For this, we multiply this differential equation with a function called integrating factor. So here integrating factor, when it's linear equations, dy by dx plus pxy is equal to qx, we are doing integrating factor. We are finding the integrating factor, we are multiplying the equation with this integrating factor. Here also we are finding an integrating factor and multiplying the equation with the integrating factor. So in general, the job of an integrating factor is to convert these differential equations into exact form or integrable form, directly integrable form. So that is the importance of integrating factor. So again, the integrating factors are defined in different ways depending on the structure of the function and the problem. So what are the different things here that we want to observe here? So case 1 is method of inspection. Case 1 is method of inspection. What is method of inspection? So we know some standard rules of differentiation. So let us, I have given some of the standard formula here that we generally come across in reducible exact equations. One is d of xy is equal to x dy plus u into formula x dy plus y dx. Derivative of y by x is equal to x into dy minus y into dx by x square. This form we have to remember very well. Similarly, d of x by y is y into dx minus x dy by y square. 1 by 2 of d of x square plus y square is 2x plus 2y dy. This is 2x dx plus 2y dy. So if you cancel 2, x dx plus y dy. So that means when I am using the word method of inspection, when I see something x dy plus y dx, sorry, x dy plus y dy, that means if you divide with 2, okay, multiply and divide with 2, you get 1 by 2, 2x dx plus 2y dy. If you integrate that, this will get. So the integral, these derivatives you have to remember very well. So the derivative of log y by x is x dy minus y dx by xy. These formulae are very, very important. Okay. So now what we do is, having known these standard results of differentiation, now we observe the different terms involved in the given differential equations. Whether those terms can be arranged into this formulae. That's what we do. Let us see how it happens. So if see y dx minus x dy plus 3x square y square e power x cube is equal to 0. So you have a term here y dx minus x dy. So have you studied any form like this involving y dx minus x dy? If you go back once, y dx minus x dy. If you see this formula, or else this formula, these two are equal because y dx minus x by x dy minus y dx. You can apply any of these two formula. So if you see here, y dx minus x by y square, if you divide throughout with y square, so y dx minus xt by y square, so that means this formula we have. Okay, plus what other terms, 3x square e power x cube is equal to 0. But what is this? Derivative of x by y directly. So derivative of x by y plus 3x square 3x, now integrate integral of d of x by y plus integral of this, we put t is equal to x cube e power t into 3x square dx becomes e power dt. So we integrate this part we get. Now x dx plus y dy. So this is df x square plus y square is equal to twice x dx plus y dy. So it's in the form. So multiply and divide with 2, then becomes 1 by 2 d of x square plus y square. On the other side, what we have, x dy minus y dx by x square plus y square. This is tan inverse y by x. This is tan inverse x by y or tan inverse y by x. If it is tan inverse y by x, it will be x dy minus y dx. So if you 1 by 2 d of x square plus y square equal to a square to d of tan inverse y by x, straight away you can integrate 1 by 2 x square plus y square is equal to a square tan inverse y by x plus c. This is what is the solution. That means you have to remember the formula very well and you have to convert the terms given in the equation into the formula, then apply it directly. So next problem. This is first case, that is equations reducible to exact form using method of inspection. The second case is mdx plus ndy is not exact. That means dou m by dou y is not equal to dou n by dou x. But if mx plus ny is not equal to 0, mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor. Okay. So I have seen some examinations in maybe PhD examinations or maybe CSR, JRF, objective questions in degree lectures, so many examinations. If mdx, the question is like this, if mdx plus ndy is not exact equation and mx plus ny is not equal to 0, what is an integrating factor for the given equation? 1 by mx plus ny, 1 by mx minus ny, mx ny. Different options are given. So the rule is, whenever mdx plus ny is not exact and mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor of this equation. So consider an example for this. Y square dx plus x square minus xy minus y square by dy is equal to 0. Is it exact? If no, find the integrating factor. Okay. So m is y square, n is this one. So dou m by dou y is 2y and dou n by dou x is 2x minus y. Clearly they are not equal. So they are not, equation is not exact. So answer for this is over. Now, if not, find the integrating factor. So what is mx plus ny? This is m into x, that means xy square plus ny x square y minus xy square minus y cube. If you cancel this xy square, we will be left with x square minus y cube, which is not equal to 0. So because it is not equal to 0, mx plus ny is not equal to 0, 1 by mx plus ny is an integrating factor. Okay. So for the solution, multiply the given differential equation with the integrating factor, that is 1 by mx plus ny, that is you take y common, 1 by x square minus y square. So the equation now becomes y square dx into 1 by y gets cancelled, x square minus y square plus x square minus xy minus y square by y into x square minus y square dy is equal to 0. Now you have to check it for exactness. That means new function m is now this one, y by x square minus 1, and new n is this one. Call them as m1 and n1. So now dou m1 by dou y and dou n1 by dou x we have to find. This is why I have written a comment, check for an exactness. Okay, so we get an exact thing. Then one because after multiplying the integrating factor just become exact, assume that just become exact. Now the same method, integral m dx assuming y as constant, because y as constant, treated as constant, I have taken this y out. So integral of dx by x square minus y square plus terms independent of x in n. This is if you take this and this one, x square minus y square by y into x square minus y square. So x square minus y square gets cancelled, this and this, then 1 by y, and the remaining term minus xy by y. This minus also goes with this. So minus xy by y gets cancelled. Still you will be left with x by x square minus y square. That term is not independent of x. So only term in n, which n1, which is independent of x, is 1 by y dy. So this derivative of integral of this is 1 by 2 log x minus y by x plus y plus log y is c. Another problem, xy dx minus x square plus 2y square dy is equal to 0. Find integrating factor if it is not exact. So dou m by dou y is x and dou n by dou x is minus 2x. Clearly my dou and nx are not equal, so hence it is not exact. So check whether mx plus ny is not equal to 0 or not. So m into x is x square y, n into y is minus x square y minus 2y cube. So x square y square, s square y gets cancelled, we will be left with minus 2y cube, which is not equal to 0. So integrating factor is minus 1 by 2y cube. So if you multiply throughout, minus 1 by 2 xy by y cube, so x by y square dx plus minus of minus plus 1 by 2 x square plus 2y square by y cube. You split the terms, x square by y cube plus 2y square by y cube 2 by y. So now this is new m1 and this is new n1. So dou m1 by dou y is minus 1 by 2y square. So my is x by y cube and this is nx is x by y cube, they are equal. So solution is integral of m1 with respect to x keeping y as constant. So this as is it comes here, and what is the terms independent of x here? This is depending on x. So this is the only term independent of x. So this becomes, this is the only term that we have, that is 2 log y. Okay, that is how we get the equation here now, solution here. And then case 3 m dx plus n dy not equal is equal to 0 is not exact equation, is not exact, anyway it is not exact equation, but in the form y into f of xy dx plus x into g of xy dy is equal to 0. See here the equation, just by looking at the equation you can identify. See, is f of x into y, not x comma y. Be very clear with this. It is f of x into y, not f of x comma y. Similarly, g of x into y. That means whenever x is there, we have x into y. X square, y square, x cube, y cube, log xy, sin xy. So terms will be, x and y will be together always. Okay. Just by looking at the equation, you can identify the differential equation. So y into dx. Another observation is f of x into y dx and g of x into y into x dy. Here I am missing it. G of dy here is equal to 0. Then if mx minus ny is different from 0, then integrating factor is 1 by mx minus ny. Okay. Let us see the example here. So some function of x into y. See here how the terms are here. So first thing is y into dx is there. Y into dx, and other terms are functions of x into y. See here. Just by looking at the equation, you can identify that x into y, x into y, x into y, y dx. And here again x into y, x into y, x into y, and x dy. This is the structure. So it's in the form y into fxy plus x into gxy is equal to 0. Still it may be exact. So if you check this dou m by dou y and dou n by dx, and they, let us say, they are not equal for this problem, so the equation is not exact. You verify on your own for this, right? I have given a statement not exact, but you verify it. Then if mx minus ny not equal to 0, integrating factor is mx minus 1 by mx minus ny. Check whether this is not equal to 0 or not. So mx minus ny is this into m into x, so y becomes xy, here x becomes xy. So xy taken out into xy sin xy plus cos xy minus xy sin xy plus cos xy. This xy sin xy gets cancelled. So xy into 2 cos xy. This is integrated factor which is not equal, because it is not equal to 0. Okay. So that's how we find the integrating factor here. Another problem is y into 1 plus xy. Here also x into y into y dx. Here 1 minus xy, x into y, x dy. So it's in the same form. So dou m by dou y is, this is y plus xy square. Dou m by dou y is 1 plus 2xy, and nx is x minus x square y, 1 minus 2xy. So they are not equal. And check whether mx minus ny is equal to 0 or not. Mx minus ny is xy into 1 plus xy into 1 minus 1 plus xy. So minus 1 cancels out. So xy 2xy into xy 2x square y square, which is not equal to 0. Hence the integrating factor is 1 by mx minus 1. Okay, that's how it happens. So we have still 2-3 methods. We have almost, the time is almost all over. So in the next class we will discuss the other methods in reducibility exact differential equations form. Okay, then we will try some more problems, and with that first order first degree differential equations will be completed. Once they are completed, then we will deal with, we'll see what are the, before going to higher order equations, we see previous gate problems and some objective questions that I have prepared for you. After solving those things only, we'll go to higher order differential equations. Okay, that is the schedule for tomorrow. So from the next day onwards, I will be directly teaching on my digital pad, just like you'll get a note like this. So as I said, some of the problems I have solved, no, I don't get direct PPT, but anyhow these PDFs will be uploaded to you, and I am telling you, I'm getting mails from you asking for the PDFs. I have already sent 2 or 3 PPTs for the first 3 days to the university, and they have not uploaded. This morning also, yesterday evening, I put a mail to them. Please upload the PPTs. The students are asking. Okay. So today I will check once again. Otherwise, I will again request them to put the PDF, upload the PPTs. Okay. So all the best for today. Thank you.